At this point, we're ready to summarize and review what we've done in this section. We talked about division of integers using the division algorithm, and we extended it to negative integers. So b and a could be any combination of negative and positive that we want. The rule that we impose is that r has to be between 0 and the absolute value of a, and that comes from our intuition of doing long division, where the remainder has to be smaller than the number you're dividing by. Still positive or possibly 0, but has to be smaller than that divisor. Q is the quotient, R is the remainder. The Q and R are unique when we impose this restriction on R. This restriction on R forces R to be only one possible thing, which in turn forces Q to be only one possible thing. And then we talked about the function div and the function mod, which when we were dividing integers and focusing on staying in the integer world, in other words, thinking about quotients and remainders, b div a would be the quotient q, and b mod a would be the remainder r. I want to make a couple of comments real quick on the exercises, two of the exercises. I want to really emphasize to you the importance of reading problems carefully. A lot of the questions I get about problems involve not reading the problem in an engaged enough way. So I'm going to demonstrate for you how you can read a problem in a more engaged way. And I'm going to mark this problem up as I read it so that you can see what my thought process is. Okay. So number 4 here says, prove that among any 3 consecutive integers. Okay, consecutive integers, I remember having these problems in algebra class where they talk about consecutive integers. Okay, so it says, prove that among any 3 consecutive integers, one of them is a multiple of 3. All right, we talked about multiple of 3. Multiple of 3, so n is a multiple of 3 if n equals 3q for some integer q. All right, so that's the problem. That's the entire statement of the problem. They give us a hint though. Let the 3 consecutive integers be n, n plus 1, and n plus 2. Well, that kind of matches up with what I remember doing in algebra whenever I had a problem involving consecutive integers. Then the hint continues to say, what are the possible values of n mod 3? Okay, I need to review n mod 3. What was n mod 3? N mod 3 is the remainder when n is divided by 3. It's asking, what are the possible values of n mod 3? We've done problems in previous sections where we explore the different possible forms integers can have when we consider 3 as kind of the central number involved. So think about what we did in the past, that might help you. Or just answer this question, what are the possible remainders when you divide by 3? What does this translate into according to the division algorithm? In each case, what would n, n plus 1, and n plus 2 look like? So think about what we wrote here. We're trying to show this. In fact, it might be better if I use a different letter instead of Q, since we used Q so much. Maybe I will use let's say x. N equals 3x for some x in z. I want you to take a moment to pause the video and think about, what did you see me do? How did you see me showing my thought process? How did you see me demonstrating engaged reading while reading this problem? And do you think I have gathered enough information to be able to answer the problem? So take a moment, pause the video, think about that, and then we'll talk about number 5. Okay, so for number 5, it says, prove that n cubed minus n, okay, well, I'm going to need this expression, is always a multiple of 3. Okay, so multiple of 3, we have that definition rewritten here, for any integer n. Okay. That means I have to be really general as possible. Be as general as possible. Examples are not good enough. So numerical examples are not good enough. Okay. And then it's giving us 2 different ways that they want us to solve the same problem. So prove this by a case-by-case analysis. So you need to think of case-by-case analysis. It's saying for any integer n, we're talking about multiple of 3, any integer of n, this problem has a very strong connection with what's done in number 4. So you might want to consider, what are the possible values of n mod 3, and see what role does that play in this problem when you're trying to do a case-by-case analysis. Part B would be to factor n cubed minus n, which would be more familiar in terms of algebra. So hopefully it was helpful to break down these problems with you, and I hope that you practice reading problems in this more active, engaged way, and that way it'll help you build your conceptual knowledge more deeply. I'll see you in the next video.